Hi everyone, my name is Christian and this is a tutorial on how to make a Parasolid example. How do you analyze it? So I'm gonna open the Patran program to start, and well, the first thing we gotta do once we open the program is to open a new file. Here, file, new. I'm gonna suggest for us to put it tension fitting as the name, as it's the name of the operation we're going to analyze. Yes, I'm going to replace it. Okay, so we have to make sure that the tolerance is based on the model, that the analysis code is MSC Nastran, and the analysis type is structural. We click OK. So the first thing we need to do is to create the geometry. So we go to geometry and we're going to create a surface X, Y, Z. So the vector coordinates list, it's going to be 5, 2, and 0. And the origin coordinate is going to stay the same. We click on apply. After that, as we're going to use the points, we can click here in home and increase the geometry of the points so we can use them. So now what we want to do is to break this surface into another one, which we are going to extrude and do some other operations on the final result. So we want to transform this point into another one right here, and this point into another one right here. So we go to geometry, transform, point, and translate, which is what we want to do. So first we're going to translate this one, and we wanted to translate 0.5 units in the x direction, and the y and the z direction stay the same. So once we have stated the direction vector, okay, one important thing over the whole tutorial is to always make sure to uncheck the auto execute option, because it's going to make some trouble if we don't do it. So it's better for us to just uncheck it and click apply after making the specifications. So as I said, once we have our direction vector, we click on point list and we uh, select this point right here and apply. So we can see how the other point just made there. And now we're going to move this one over here. So we wanted to move 0 in the x direction, 0.5 in the y direction, and 0 in the z direction. We apply, oh sorry, we need to select the point we want to apply the direction vector to. We select this point and then we apply. So after that, um, now we're going to create a line or a curve between these 2 points. For doing so, we're going to geometry and we want to create a curve, and the method is going to be by points. The starting point, it'll be this, it could be the other one, it doesn't matter, and the ending point is this. We as you can see, I didn't uncheck the auto execute, so once I filled this blank spaces, it auto executed and made the line. But this, I mean, if I've made a mistake, um, this could be bad, so I'm just going to uncheck it. I'm not going to click apply because it already applied to the surface. So now we want to break this surface into 2 pieces. For that, I'm going to edit the surface and break it. The surface we want to break is this, and we want to break it by this curve. And yes, we click on yes. And once again, I didn't uncheck the auto execute and it did it for itself. Um, so, okay, in order for us to see the break, we can go here to home and refresh graphics. So now we want to delete this triangular surface that we have separated from the rest of our geometry. So for that, I'm going to delete a surface, and we're going to select the triangular surface. We apply it. So now we have deleted. Now we want to extrude this surface we have to create a solid. And for that, we're going to create a solid by extruding. So the translation vector that we're going to input here is going to be 0 in the x direction, 0 in the y, and 2 in the z direction. We have to make sure that the set measurable solid icon is selected here. And well, since it was okay, so I'm gonna uncheck how to execute. I'm gonna select this surface, and then I'm going to apply. Now that I applied, if I want to see it, I can go here to the ISO one. We can see the extrusion, and also I'm going to click on smooth shaded so we can look at it as solid. So now we're going to edit some geometry. We want to create a shell. So we stay here. We go to geometry. We're going to edit a surface. No, sorry. We're going to edit the solid, and we're going to create a shell. The thickness is going to be 0.25, and this, so I'm going to check the auto execute. And now we want to select these three faces right here in the solid. And in order for doing so, um, you're going to use the shift, so you can click on the three surfaces and select them at once. Once they are like this, then you apply it, and you have your solid shell. And now we want to make some fillets, and we go right here to edit again solid, and we're going to do some edge blends. 0.25, it's going to be our constant radius, and we need to make sure that these two icons here are selected, so we can then select the edges we want to be blended. So again, using the shift technique, we're going to select these four edges right here, the inside edges. This one's a little bit tricky. 2, 3, and this two, 4, and 5. Once we've selected all, we click on apply. We can see that it blended the edges or made some fillets. The next step is to create the hole here for the um, so first, in order to extrude or to make a hole here, we need to create the geometry and then delete it. So we're going to create a geometry, a solid, sorry. It's going to be primitive because it's going to be a cylinder. We select it here, and the parameters for this cylinder are going to be 2 for the height, and it's going to have a radius of 0.25. The base center point is going to be -1 then 1.25 and 1. In the axis list, it's going to be the point 1. Very important to have these parameters right so we won't commit any mistakes in our geometry. So we click on apply. We can see that the cylinder created, and subtract icon. Okay, so now we're going to subtract this immersed cylinder that we made. For that, we go to edit, solid, and boolean. And we need to select the subtract icon, which is the middle one. So the solid we want to subtract things from is the whole solid right here, and the solid we want to subtract from it, it's the cylinder. So we choose it, and voila, here it is. That's all. So now we want to create some holes right here in the center. And from that, we are going to need to make first some points on it, and then make the holes just like we did it with this one. So for us to make it easier, I'm going to change the view to a wireframe, as we're going to make a translation of points just as we did at the beginning. And well, here I go to transform a point and translate. So we want to move one of these ones. I'm going to choose this, and if you want, you can use this, but you're going to change the direction vectors I'm going to give you. So use this, and well, we're going to enter a. We're going to move this point to 0 units in the x-axis, 0 units in the y, and 0.5 in the z direction. Remember to uncheck the auto execute. So it's here in the point list you have to select this point, but it's already selected, so I'm just going to apply it. We can see that it moved just to the center as we wanted, and now we want to move this point to particular positions here along the piece. So we use the same command, but now we want to move it upwards. So the new direction vector is going to be minus 0.75 in the x direction and 0 in the others. And now we want to move this point. We click apply, and it's unable to process because I did commit a mistake here. So I'm just going to correct it. We can see the vector magnitude here, just to make sure that you didn't make any mistakes here. So again, we select the point and we apply. We can see that we create a new point, and now we want to make some other 2 points along this line. But the new direction vector is going to be minus 1.5 and 0 in the other direction. Sorry. Now, as we want two other points, we're going to repeat this translation parameters times 2, and we're going to select this point, and we're going to apply. We can see that we made the other two automatically, which is very cool. Okay, now I'm going to pass to an smooth shader vision um, for the next application. So we're going to create 3 cylinders here, and then we're going to remove it for us to have the holes. And again, as we did at the beginning, we're going to create a solid primitive cylinder The specifications for this is going to be -1 height and a radius of point 125. So I'm just going to make sure that I'm still recording because okay, yes I am. Well, yeah, the radius is going to be point 125, and we're going to use the shift again technique to select the three points as the base center, which is selected right here. So we click on shift. I can okay, shift select this point. The other one is okay. So I'm gonna change to Wi-Fi. We're gonna select this one. Okay, so here you can change the point so to make it easier. Uh, I had the auto execute option, so I made a mistake, but we can go back two times. Okay, so the height it's -1, radius 0.125, and with the auto execute unchecked, we're going to select the 3 points here to make a cylinder, and the axis list is going to be let me see, it's going to be chord um, 0.2, and then we click apply. And the cylinders were made. We can see here in the smooth shader view. They now we're going to subtract them from the rest of the solid. So as we can remember, we edit a solid with a boolean. We're going to subtract it, and the solid we're going to subtract, okay, is the whole solid here, and the solids we want to remove are these three cylinders. So we select them with the shift technique and then apply. And now we have our holes there. Okay, we have it like this. Okay, we apply. And after doing that, now and we want to create a point in the center of the large hole right here in order to create a cylinder to imprint onto the solid. So I think I already have a point. Well, no, I'm going to make it. Sorry. So I change to wireframe again, and I'm going to create a point. And but right now we're going to use a method of arc center. So the curve we're going to use to create a point is going to be this, and you can see that we created that as I had auto execute on. It made it without me applying it, which is cool. Um, Now I'm going to create the again a cylinder. So I'm going to create a solid, primitive solid, which is a cylinder, and the specifications for this one are going to be 1 for the height list and 0.371 for the radius, which is a very broad radius. Click on point the center. Okay. Mm, The base center point is going to be the one that we created, which is this one. And the axis list, it's going to be chord point 1. Mm, After that, we click apply. You can see that we made the cylinder. And guess what? Yes, we're going to remove it again. But now we're going to use the cylinder to imprint the solid so we can make another calculations in the future. So we're going to edit the cylinder, edit the solid with a boolean. We're going to imprint here. So the solid we want to to be imprinted is the whole solid, and the one we're going to remove is this. So as we can see, we have already imprinted this radius on this solid, which is what we wanted. And now we're going to delete the cylinder. So we go here to delete solid, and we're going to choose this solid, and we apply. We can see that it deleted, and we're almost finishing. So now we're going to create the mesh for to analyze this piece. So we go here to meshing, and we're going to create a mesh in the solid, and we want to remove check for automatic calculation here, and we're going to set it to 0.25 for global edge length, and then you are going to click on apply. So I don't have a license that allows me to do a global edge length of 0.25, and this program won't work if I do it so, but you can do it if you have the complete program. But for tutorial purposes, I'm going to use a 6 units for the mesh, which is going to be a more weak mesh, but it's going to show you how this works. So I'm going to click apply. The solid select maybe too small or open. Okay, so I didn't select what solid I wanted to mesh. I'm going to select it here, and now I can apply, and we can see here how the mesh created itself, which is very cool. And now mm, 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 now we're going to create the loads that our solid is going to be having. So we go to the loads BC. We're going to create a load, a pressure. No, sorry. We're going to create a force, and that's going to be nodal. And so here I input the data for the force, which is going to be minus 5,000 in the x direction and 0 in the other ones. Then we're going to click OK. Now we're going to select the application region, and we're going to select the vertical solid face created by imprinting at the larger hole, which is this right here, this ring. In order for us to select the surface, we need to make sure that here we have surface selected. So select geometry, and we select this, we add it, we click OK, and we apply. Okay, so I did it. I forgot to put a name to this, which I'm just going to call force. Oh, force right there. It's our first force, which we can see it's applied here because it's already added. So we click OK and apply. We can visualize our force being applied there. And now I'm going to create a constraint at the base holes right here. And so I'm going to create a displacement that is going to be nodal. So the data it's only going to constrain the translation of those holes. So I'm just going to put 0, 0, and 0 here. I'm going to click OK. Going to select the application regions. Once again, we select surface here, and by using the shift technique, we're going to select this tree. Um, this tree. Okay, you need to make sure that you can see both ends of the hole, so you can make sure that you're selecting all of it, all of this surface. So I have already selected them, so I'm going to add it, and click on OK. And yes, okay. So now I'm just going to apply. And once again, I forgot to put a name, which I'm going to put just as fixed. Apply. Okay, so our next step is to create a material, the material of which our piece is going to be made. For doing so, we come here to properties and we create an isotropic material, create isotropic and manual input. The name of our material is going to be aluminum, and the properties of this aluminum is going to have a 30 megapascals, which we can input as 3E6, and a Poisson ratio of 0.3. We click OK, and that's going to be all to create a material. We apply. We can see that it created the material here, and now we want to create a 3D property for this tension fitting piece. For doing so, we go to create 3D anisotropic, or we can go here and select solid. I'm going to input, sorry, create. Okay, so yes, we're going to apply the material that we just made to this piece. Sorry. Here in input properties, we're going to select this icon of the map prop name. So, and we're going to select the aluminum, and we click on OK. And for the application region, we're going to select the whole solid. Sorry. For doing so, we can make a box that so we can select all the solids we added, and we click OK. And now we click on apply. Property, but this is not a property. Create 3D solid, and okay, so I guess we can call it 3D. That's it's not really, I mean, this is how you're going to know that your program works, but you can put any name you want on it. Now we want to check the load case and make sure that the loads and constraint are selected, and for that we go here where it says load case. Where is that? Load case. We select default, and we can see we have one displacement and one force. This force and the displacement in the three holes, which is correct. And now we're just going to click cancel because we only wanted to check, and we can start our analysis now. So we go here to the analysis, we select entire model and full run. Now this is entire model full run, and we click okay, we need to make sure that the solution type is going to be linear static, and that the job name is the one we want to make, which is the tension fitting. So we apply, we can see that it's sent it to Nastran and already proceeded. Okay, so once you make this, uh, you can see that it creates an XDV. Here it has tension fitting, and these are all of the files that the program created for you. We can see that we created an XDV file, which is going to be the one we're going to use to analyze and process. So that's the next step. You go to analysis, XDV, and we're going to click on select result files. that is here, and we go to your folder, which for me is going to be here, tutorial, terms of reading, and apply. So that's going to be all. Now, um, so we applied the results to our piece, and in order for us to visualize them, we go here to results, and we're going to create a deformation because we want to see how much it deformates. So we select this only option we have on select result cases, and we're going to select displacements relational in the deformation result, and we apply. So okay, here guys, so already okay, well, we had a problem with the mesh we made before, but here's the correct example of what you should have visualized, which is the formation of the piece. And in order for us to see it in a better way, what we're going to do is to erase the original geometry by going here to display, plot erase. We're going to erase the geometry so we can see just the deform. So maybe your computers you'll see it different because I already made some arrangements for it to look this way, which I'm going to show you right next. So we're in here on results, creating a deformation, and we're going to click here in the display attributes. And what I did in order for it to show it like this is that I choose I remove the check from the show on the form, and for the render style I use um, here shaded. Here, sorry, I use shaded. Now I apply it, and I'm having this. And after that, you can see uh, in your computers how you can see this piece, the form, but without the colors. So for you to see the results, you're going to go to the results tab and create a fringe. You're going to select this option, and here you're going to select the least one, which is the last one, sorry, which is the stress tensor. And now you're going to click on apply. No, sorry. Up before you click on apply, you're going to click again here in display attributes, and you're going to choose uh, here element edges to display. You're going to click apply. So now you can go back and click apply. And by doing it, you're going to have this that you're looking in my Patran that has all the colors and the scale right here that shows us the forces and deformations acting upon our piece. So that's going to be all. Thank you all for listening, and that's all.